Okay, one of the most important things that we need to talk about after we've done our data analysis, we've collected data, we've made our improvements and everything else. We need to determine if what we have done has made any difference. And so what we're going to look at today is our two tests that we can use to determine if there is a difference between our before and our after. And the two things that we're going to talk about is a T-test and ANOVA, which is analysis of variance. So what I need you to be able to do first of all is you need to have data analysis tool pack added into Excel. You can see it over here on the far right hand side. To make sure that you have that, go to File, down here to Options, and under Options you'll see Add-ins, and then Manage Excel Add-ins are down here on the bottom. Click Go. Make sure you have your Analysis Tool Pack checked again. Click OK, and at that point you should have data analysis that pops up here at the top. We have two different scenarios here. First one is just a simple one treatment type thing. Here's where we were before we started our Six Sigma project. This is what happened after we implemented some change. So to do that, this is just two items, and for two items this is going to be an Excel T-test with two samples. Now you could say that, I mean, in a very simplistic way, if we just looked at these things and said, hey, what's our average before and what's our average afterwards, I've calculated those for you down here. That's the before average, that's the after average. But remember, these are just samples, and so with a sample we have variance associated with that sample. And if you can take yourself back to the back to your stats days, we have a mean that's different than this mean. However, we know it's a sample, and you can see here I've calculated the standard deviation down below it. And so we have a mean on a sample, but that really is just a sample. If we went back and took another sample of another 30 days, it may be something completely different. So we have this center point, our mean, about 12.6 days, but we have a bit of a wobble, if you will, and that wobble is how much it would change over different samples, and the standard deviation is 4.8 for that. So is there enough of a difference between this 14.1 and this 12.6 here? Or is it possible that if I resampled before, a group of before another month, that number would be bigger than 14? So statistically we have a way to check that. That's called an Excel T-test. Two samples, assuming unequal variances. There are our standard deviations right there, and so they're not the same, so it's definitely unequal. The way we're going to do this is we're going to go up here to Data Analysis. These are the options you have in your analysis toolkit. We're looking at a T-test, and we're looking at a two sample assuming unequal. Click OK. It pops up and says, hey, what's your first variable? And so our first variable is, I'm just left clicking and dragging. That's before. Our second variable is after. I'm just going to take and click here and again drag it. As I drag this, please note that these two don't have to be the same length. You could have more data in this column than that column. It won't matter, just make sure you put it all in there. Your hypothesis should be that nothing really changed. Okay, so the hypothesis mean difference is my treatment did nothing. So you need to put a 0 in this. You need to tell the sheet here that you have your labels included, and all that's saying is that you did capture the very first step. So it's not gonna use those two things. The labels are there. Alpha level of 0.05. Again, think back to your statistics. An alpha of 0.05 means that this is a confidence interval of 95%. 1 minus alpha equals confidence level. Okay, so this is a 95% confidence level. You're asking it right now to go ahead and give it to you in a new worksheet. You could tell it somewhere else to go or whatever else. However, we're all set up. and we're comparing this string of variables to that one. We don't think that there was any difference. We want our labels included. 5% alpha, which is 95% confidence. Click OK. And now it's time for you to look at your results. I'm going to just double click this, open it up. Here's the way you look at your results. It comes out and says, if you want to look at this data, we already knew that this was the case from what we had done before. There's the mean, there's the variance, there's the number of observations, and now it says, are we talking about a one-tail or two-tail? And remember, you remember how the bell curve goes up and then comes back down again. The tail is, we have a left tail here, a right tail over there. We're really thinking in this one that our treatment, it could have been worse or it could have been better. So that means two tails. If we were only looking at, we wanted to make sure that it got better, then we would be talking about a one tail. Inside of Excel, it will tell us straight up. It says if we're looking at for a t-crit value for a two tail, it needs to be 2.00 is the critical value. That's the threshold. It would have to be our T-stat here. Let me go ahead and highlight this. That's our standard. That's the standard we have to get to, but what did we get? We got that. What we would need to say there was a difference, and this is actual value. So in this case here, our T-stat is less than the critical value, so there was no change. Or let's don't say change, there was no statistically significant change. Okay? So that's how you do a t-test. You just go collect your data, put it all together, make sure that whenever you do it, you have it in this column format so that you can compare before and after. The next one that we're going to look at is analysis of variance, and you can see for an ANOVA, we're going to just look at a single factor. The single factor that we're looking at right now is whatever this variable is that we were measuring. And for an ANOVA, the difference between a t-test and an ANOVA is this just has a before and an after. ANOVA says, give me a whole bunch of different things that could have happened. Give me a before. Give me something a treatment 1, a treatment 2, and a treatment 3. So with that said, let's go back again to our Data tab and Data Analysis. Come back up to ANOVA Single Factor. Click OK. What data am I looking at? I'm going to go ahead and left click, drag, and you'll notice this time that this treatment group here has more data points than that. Don't worry about it, just make sure it's all there. Back over here now, grouped by columns instead of rows. I included labels in my first row. Alpha of 0.05, which is a 95% confidence interval. Put it in a new worksheet. Click OK. It's thinking, it's working. Okay, now it's popped out here an example for us again. Just like before, the values that we're looking for are here. That's the critical value that we need to be able to determine whether or not we have a difference. So this is what Excel says we need to determine a difference. And this time, our F value, that is what we got. And so from this one, you can see that our F value is larger than our critical value. So since f is greater than f crit, then we can say that there is a statistically significant difference. Okay, and that's at the 95% confidence interval. With that said, now going back up here to our data, it says something is different. Something is different between these four. We can't specifically say that there's something different between 1 and before or 2 and before, but something is different, statistically different between these four groups of items. And you can kind of see that this average there is our largest, and that is our smallest. So an ANOVA may be saying that statistically 2 is different than 3. It may not be specifically saying that 2 is different than 1, the before. If I wanted to specifically look at 2 versus 1, then we would go back in and just do a regular t-test like we did before. However, the ANOVA does say I have 4 things that happened. Something is different than, or one of these sets is different than the other. So hopefully that gives you an idea of where to go with this, how to go back in and look at it. I'm going to try to keep this as short as I possibly can, but hopefully that will get you up and rolling and be able to determine if something has changed over time.